Now see here, suppose for example, let me take this first conversion. What we did, first conversion is sin A cos B. Now everyone tell me the value for this. Let us not go to the screen and copy from here and write it here. Let us understand once again. It is half. Sin and cos are different. Express in terms of sin. Express in terms of sin. One of the time add it, other time subtract the angles. Now if I continue, it is closer to cos. Equals is closer to cos. Cos is positive, put plus sign here. Now think logically, sir. Think logically. Instead of learning the next transformations, the next 4 transformations is nothing but my case 2. What should be my case 2? Case 2 is nothing but if some more difference is present on the left hand side, how to convert it to product? How to convert some more difference into product? This is nothing but, can I say that this second case is nothing but the reverse of first case? Think logically, sir. Try to connect the dots here. Can I say that here starting I wrote product. The same product in the heading I am writing at the end. Starting and ending are nothing but reverses of each other. Similarly, some more difference in the heading I wrote it at the end. The same some more difference I wrote it at the start here. That means they both are reverses of each other. That means, can I say that? Please try to connect the dots like this. It will be very, very easy. Whatever I am writing at the starting, I will write it at the end here in my second. Whatever I am writing at the ending, I will write it at the start here at my second case. That means I will reverse their positions also, right? I will reverse their positions also. That means, can I say that whatever I wrote it on right hand side, I will write this time at left hand side. Similarly, whatever I wrote it at left hand side, I will write it as right hand side values. And this 1 by 2 also convert it to multiplication. Cross multiply, this 2 will go on the right hand side, it will cross multiply. Now think logically, sir. A is one angle, B is another angle. If I add 2 different angles, I will get another angle called as C, for example. If I subtract the same 2 different angles, I will get another angle called as D, for example. Now A plus B is C, A minus B is D. If I simplify, A plus A is 2A. 2A is equal to right hand side is C plus D. A will be equal to C plus D by 2. If I substitute this A value here or here, I will get another value of B. B I will get it as C minus D by 2. You can check it out and by substituting and getting it. Now instead of remembering case 2, can I say that this wherever A plus B is present in my right hand side, I will call it as C. And I will write right hand side terms on the left hand side. Sin C I wrote plus, this plus I wrote as it is. Wherever I have A minus B, I will call it as D. I wrote it on right hand side earlier, now I will write it on left hand side. This 2 cross multiplied, 1 by 2 cross multiplied, it becomes 2 by 1, which is 2. Here, can I say, wherever I have A, replace it by C plus D by 2. So it is a sin of C plus D by 2, right? It is sin of C plus D by 2. Wherever you have B in the left hand side, replace it by C minus D by 2. It is cos of C minus D by 2. Over, sir. You don't need to by heart anything. When it is required, derive it in the examination for 2 seconds. Move on. No need to by heart anything. I never asked you to by heart anything in my classes as long as it is definitely required to by heart. In any topic you take it, sir. I don't ask you to by heart any formulas in arithmetic. But when it comes to algebra and trigonometry, yes, you need to know some of the trigonometric formulas. But in as much as possible, I will ask you to remember in these shortcut methods rather than to by heart. I hope you are understanding. Whatever is there on the right hand side in my first case, put it on the left hand side and replace A plus B by C, replace A minus D by C. Whatever is there on the left hand side in my first case, put it on the right hand side. That's all you need to know. You interchange the positions also. Over. That means replace A with C plus D by 2. Replace B with C minus D by 2. I hope everyone is clear. Suppose if I take my second case, cos A cos B. Now try to tell me the answer right now, sir. Very easily you can tell me. What should be written on the right hand side? First of all, what should be written on the left hand side? This right hand side value should be written on the left hand side. Forget about this half. This 2 I will anyway cross multiply. Right now, A plus B replace with C. I will get sin C minus C. A minus B replace with D. I will get sin D. This value I will put it on left hand side. That means it becomes sin C minus sin D. Where is the difficulty here, sir? It will become sin C minus sin D. This 1 by 2, whatever you wrote on the right hand side, cross multiply there, it plus D by 2. It is cos of C plus D by 2. And sin B you have. B replace it as C minus D by 2. Sin of C minus D by 2. Sir, your second transformation in my second case is over. Listen carefully. Now, can I say that this anyway we will discuss in our coordinate geometry later on, but I am just telling you the basics, and this is extremely important, sir. Do not ignore this. If you ignore this particular concept, many questions in your trigonometry might seem very difficult, which are actually very easy using this concept. Now see here, we all know that there are 4 different quadrants in our coordinate geometry, right? There are 4 different quadrants. First, let us understand the concept, then we will use what is required to remember, right? There are 4 different quadrants. This is my first quadrant. First quadrant will vary from 0 to 90 degrees, right? It will vary from 0 to 90 degrees. Second quadrant, it will vary from 91 to 180 degrees, right? It will vary from 91 to 180 degrees. Third quadrant will vary from 180 degrees to 270 degrees, right? 181 degrees to 270 degrees, right? Third quadrant will vary from 181 degrees to 270 degrees. And the last quadrant, fourth quadrant, from 271 degrees, it will vary till 360 degrees, right? It will vary till 360 degrees, and after 360 degrees the entire circle will be formed. It will again come back to my initial position where I started my journey, right? Wherever I started my journey initially, I will end up with the same position and I will start my journey once again. That means after 360, whatever you are getting is nothing but again starting from 0 degrees. Both are same, right? Now see here, sir. Now see here, listen carefully. Can I say that if I draw a right angled triangle here, right? If I draw a right angled triangle, listen carefully, sir. First we will understand with a diagram and then understand the concept. If I draw a right angled triangle, this angle I will call it as theta. Everyone listen carefully. This angle, if I call it as theta, this will be hypotenuse. This will be hypotenuse. Can I say that in first quadrant, first of all, this particular line, whatever I am drawing, this is positive, right? This is positive. This particular line also, whatever I am drawing, that also is positive. That means in first quadrant, these two are positive. In second quadrant is y axis is positive, x axis is negative, right? X axis is negative. That means second quadrant is minus comma plus, first quadrant is plus comma plus. You all know, already know these things. Let us derive something out of these things. Third quadrant is x axis is negative, y axis is also negative. Third quadrant is negative comma negative. Fourth quadrant is x axis is positive, y axis is negative. It is positive comma negative. It is always a convention to take x axis first and then y axis in our coordinates, right? Now see here, can I say that in this right angle triangle, this particular value is positive, right? This particular value is positive. Similarly, this particular value is also positive, right? This is also positive. Hypotenuse is given by square root of opposite square plus adjacent square. Can I say like this, sir? Opposite is nothing but positive plus positive square plus adjacent is also positive square. When I square a positive number and add it in the square root, ultimately square root also will give me a positive value. Or in simple language, can I say that, sir? Hypotenuse, square root function will always return a positive value. Square root function will always return a positive value. That we will also study in our algebra class, right? Square root function will always return a positive value. Now think logically. If I apply sine of theta, if I apply, I am just going in depth for this particular concept. You need not remember all these things for your examination point of view, but let us learn it when it is a time to learn, and then we will unlearn it when it is a time to solve our problems. If I apply sine theta is nothing but opposite by hypotenuse. Opposite is positive, hypotenuse is also positive. Positive divided by positive is positive. Suppose if I apply cos theta, cos theta is nothing but adjacent by hypotenuse. Adjacent is positive, hypotenuse is positive. Adjacent positive by hypotenuse positive. Positive by positive is again positive. That means like that, keep on checking with all the other trigonometric functions, all the other derived trigonometric functions. Everything, when you divide one by the other, when you apply the definition of trigonometric functions, the final value will, everything will be positive only. That means in my first quadrant, all the trigonometric functions are positive. All the trigonometric functions are positive in my first quadrant. You know that all are positive in the first quadrant. How all are positive? That is what I explained you right now. I am more interested in digging you deep into the basics initially, for you to bounce back and say that, wow, the world is so beautiful outside. Now see here, that is the first quadrant. If I come to my second quadrant, where the angles are varying from 91 to 180 degrees, can I say that in this particular second quadrant, if I draw a right angle triangle in the second quadrant, if I draw a right angle triangle in the second quadrant like this, can I say that this is nothing but 90 degrees? This will be hypotenuse. Hypotenuse is square root of something which will always return a positive value. This is nothing but, can I say that in second quadrant, x-axis is negative, and in second quadrant y-axis is positive, which I already have written here as plus v positive. Hypotenuse is square root of something which will always return a positive value, right? Now think logically, sir. If I apply sine theta, if I call this angle as theta, for example, if I call this as theta, if I apply sine theta is opposite divided by hypotenuse. Opposite to theta is positive, right? Opposite to theta is positive divided by hypotenuse is also positive. Positive divided by positive is positive. That means if sine theta is positive, cosecant, which is the reciprocal of sine, that also will be positive, because it will be again reverse by reverse, positive by positive, it will come as positive. Suppose, just check with cos theta, sir. Just check it out with cos theta now, so that you will understand it better. If I apply cos theta is adjacent divided by hypotenuse. Adjacent to this angle theta is x-axis. In second quadrant, x-axis is negative, right? It is negative. Adjacent is negative divided by hypotenuse is positive. Negative divided by positive is how much? It is negative. That means in my second quadrant, only two trigonometric functions are positive. And which are those two trigonometric functions? Sine is positive and its reciprocal cosecant is also positive. I believe that you are very, very clear with the concept which we are discussing, sir. I am more interested in conceptual learning rather than learning something else which is given in textbooks, right? I am sure that it is very, very clear with the conceptual learning. In second quadrant, other trigonometric functions other than sine and cosecant are negative. Only sine and cosecant are positive. If I come to my third quadrant, where x-axis is negative, y is also negative. If I draw a right angle triangle in my third quadrant, so this becomes my right angle triangle, right? If I call this angle as theta, right? If I call it as theta, now see here, sir. Same idea, sir. No change in the approach. Suppose, for example, in third quadrant, y-axis is negative, x-axis is also negative, which I wrote here as minus v, right? In third quadrant, suppose if I apply tangent, tan theta, if I apply, what is the basic definition of tan theta? Tan theta is opposite by adjacent. Opposite to theta is nothing but y-axis, which is negative, divided by adjacent to theta is nothing but x-axis, which is also negative. Negative divided by negative is positive. Tan is positive. If tan is positive, cot is reciprocal of tan, that also will become positive. Remaining any other trigonometric functions you take, like sine or cosecant or secant or cos, all of them will definitely, when divided by one by other, it will give you a negative value. You can check it out, sir. I am not asking not to check it out. You can check it out and prove it with yourself. And the last quadrant is, it is nothing but fourth quadrant. If I draw another right angle triangle in my fourth quadrant, if I, these are nothing but 90 degrees, if I call this particular angle as a theta, if I call this particular angle as theta, in my fourth quadrant, x-axis is positive value, y-axis is negative value, y-axis is negative, hypotenuse is positive, here also hypotenuse is positive. Same logic, sir. If I apply cos theta, cos theta is definition is adjacent by hypotenuse. Adjacent to this angle theta, is x-axis, it is positive. Hypotenuse is again positive. Hypotenuse will always be positive. Positive by positive is positive. Cos theta is positive. Reciprocal of cos is secant. Secant theta also will definitely give you plus by plus, which is positive. Suppose if I take sin theta, for example, sin theta is opposite by hypotenuse. Opposite to this theta is nothing but y-axis, which is negative. Hypotenuse is positive. Negative by positive is negative. So sin theta is giving you negative value in the fourth quadrant. That means only two trigonometric functions are positive again in fourth quadrant, which are nothing but cos and its pair, or the reciprocal pair, which is secant. This is the concept behind learning allied angles. Whatever I have taught you right now is a concept called as allied angles, and allied angles is an extremely important concept for your problem solving in your examinations, sir. Extremely important, I can say it. It is damn important. You should definitely know it, right? Allied angles is the concept which we studied just now in detail, in depth. Kindly comment in the live chat if it is clear for you. Next, we will continue the same concept of allied angles to learn so many other things. Listen carefully. Listen carefully. Now, I will rewrite this four quadrants. I will rewrite it. Listen carefully, sir. Again, we will learn something else to make our problem simpler. Now, can I say that I already told this is my first quadrant, 0 to 90. 91 to 180 is my second quadrant. 181 to 270 is my third quadrant. 271 to 360 is my fourth quadrant. Let me write those things also, so that our understanding will be much more clear. 0 to 90 degrees, 91 to 180 degrees, 181 to 270 degrees, and the last one is 271 to 360 degrees, right? 271 to 360 degrees. Now, everyone listen carefully, sir. Can I say that right now I am at a initial, okay, first of all, this is x-axis, this is negative x-axis, this is positive y-axis, this is negative y-axis, right? This is negative y-axis. Right now I am at this position. I am at a position called as 0. this is 0 degrees, right? Right now I am at 0 degrees. Now I will keep traveling like this. I will keep traveling like this, and I will complete the entire circle. Although the diagram is not drawn to the scale, assume that as a circle, right? I will keep traveling like that, and I will complete the entire circle. Now see here, if I start traveling, if I want to move on to my second quadrant, suppose if I call theta as an acute angle, let theta be some acute angle. Anything which is less than 90 degrees is an acute angle, right? If I call theta as my acute angle, can I say that for this 0 degrees, I will push something to this 0 degrees. If I push 1 degree, it becomes 0 plus 1, 1 degree. 1 degree is in the range 0 to 90. If I push with 3 degrees, it is 0 plus 3, it is 3 degrees. 3 degrees also in the range 0 to 90 degrees. That means, can I say first quadrant is 0 plus some angle theta, right? 0 plus some angle theta. Can I also say that it is also equivalent to saying, suppose for example, I have 89 degrees. 89 degrees can be written as, from this 0 degrees, I will add some angle 89 degrees. This 89 should be an acute angle, right? I will add some angle 89 degrees so that I will get 89 degrees. Or it is also equivalent to saying it as, from 90 degrees, I will subtract this acute angle 1 degree so that I will get 89 degrees. From 90 degrees I will subtract 1. That means I went on to second quadrant. I am jumping back to first quadrant by eliminating some angle which is 1 degree in this example. That means first quadrant can be written as 0 plus theta, or it can also be written as 90 minus theta. I believe that you are very clear with the concept, sir. 0 plus theta is the first quadrant. 90 minus theta is also first quadrant. Similarly, second quadrant. For it to become 91, for 90 I can keep here first quadrant I will take the base as 0 degrees. Second quadrant my base is 90 degrees. For 90 degrees if I add 1 degree I will get 91. For if I add 2 degrees I will get 92 and so on. That means this is nothing but 90 plus theta, right? 90 plus theta. The second quadrant can also be said as, suppose if I am in my third quadrant, I want to jump back to the second quadrant. From 180 degrees which I am in the third quadrant, I will subtract some angle, acute angle theta. I will be staying in my second quadrant itself. So 90 plus theta or 180 minus theta, both will actually represent my second quadrant. Similarly, third quadrant, if I call this base as 180 degrees, right? My base is 180 degrees for entering the third quadrant. For this 180 degrees, I will add at least minimum 1 degree so that it becomes 181 degrees, so that I will jump to my third quadrant. Or in other words, suppose if I had jumped to the fourth quadrant, if I wish to stay in my third quadrant itself, I should subtract something from 270 degrees, because fourth quadrant will start from 270 degrees, right? 271 in fact. From this 270 I should subtract something which is an acute angle so that I will stay in my third quadrant itself. And the last quadrant, fourth quadrant, is for this 270 which is my base value right now, add some acute angle so that I will jump to my fourth quadrant. So 270 plus theta is my fourth quadrant. Or I can also say, suppose I completed my entire circle, which is this is nothing but 360 degrees. So 0 can also be written as 360 degrees. Both are absolutely the same. From that 360 degrees, I will subtract some acute angle theta so that I will be back to my fourth quadrant itself. Or can I also say like this, sir? 360 degrees is absolutely same as 0 degrees. So it is 360 minus theta can also be said as 0 minus theta. That means fourth quadrant there are 3 ways of representing. In fact, after this 360 degrees, if I want to come to my first quadrant, add something. So 360 plus something will give me equivalent to 0 plus something. 0 plus theta can also be written in the first quadrant as 360 plus theta. I believe that these particular values which I have explained in this particular graph and in this particular graph are again absolutely clear with the concepts. Kindly again comment in the live chat, sir, which angle, which quadrant will have what all variations. That is something which you need to know to understand allied angles better. I hope everyone is clear. Everyone who are listening to this concept should be extremely damn clear with all the conceptual clarity. This is one part of the graph. This is my second part of the graph. Idea clear, everyone? Now, what is allied angle? Now see here, sir. This same diagram I am writing it here again for your better understanding. What is allied angle? First let us understand with, now if I draw with this diagram, first quadrant, second quadrant, third quadrant, and then the fourth quadrant. Now everyone listen carefully, sir. Can I say that this first quadrant, all the trigonometric identities are, all the trigonometric functions are positive. First quadrant, all are positive. Second quadrant, sine and its reciprocal cosecant are positive. Third quadrant, tan and its reciprocal cot are positive. Fourth quadrant, cos and its reciprocal secant are positive. That means, can I say that if I take first letter in each and everything what I wrote, in first quadrant all are positive, I write it as A. Second quadrant, sine is positive, anywhere the reciprocal is known to you, sine is starting with S. Third quadrant, T is positive tan, it is T. Fourth quadrant, cos, it is C. It is also called as ASTC rule, right? It is also called as ASTC rule. Now can I say that whenever, listen to this statement very carefully, sir, whenever it is mentioned in the question as 90 plus or minus theta or 270 plus or minus theta, can I in general say that this 90 is an odd multiple of 90, 270 is also an odd multiple of 90. Can I say that whenever it is nothing but 90 plus or minus theta or 270 plus or minus theta, or in general whenever it is odd multiple of 90, whenever it is odd multiple of 90, you should change the trigonometric identities, right? You should change the trigonometric functions, in fact not identities, you should change the trigonometric functions. But whenever it is 0 degrees, 0 plus something, or 180 plus or minus something, or 360 plus or minus something, 180, 360, 0, all these things are even multiples of theta. It is not 90 which I am taking here, it is theta I am taking in general, right? Even multiples of theta, or in other words it is multiples of 180, right? It is multiples of 180. You need not change any trigonometric functions. That means easy way to remember is when it is 90 plus or minus theta or 270 plus or minus theta, change the trigonometric functions. When it is 180 plus or minus theta or 360 plus or minus theta or 0 plus or minus theta, do not change any trigonometric functions. Now what is the meaning of changing trigonometric functions? Changing trigonometric functions means how you need to change. Suppose if you have sine as your, what is the trigonometric functions, sine should be changed to cos, cos should be changed to sine. This is happening only if it is 90 plus or minus or 270 plus or minus, sir. Similarly, tan should be changed to cot, cot should be changed to tan. Similarly, secant should be changed to cosecant, cosecant should be changed to secant. Sir, are these the reciprocal relations? Not in all the case. Only tan and cot are reciprocal, sine and cos are not reciprocal. Please remember, secant and cosecant are not reciprocal. That means whenever it is 90 plus or minus theta or 270 plus or minus theta, you should change sine into cos or cos into sine. secant into cosecant, or cosecant into secant, tan into cot, or cot into tan. But sir, why should we change like this? Why are we changing 90 plus or minus theta or 270 plus or minus theta from sine to cos? Is there any particular reason why sine is changed only to cos if it is odd multiple of theta? Kindly explain with logic or explanation. But before that, is it clear for you, sir? Whatever we have written on the right side of the screen as of now. Kindly comment. Every step I want to hold my hands of students and say that we are there with you, you need not worry. That is the kind of confidence I want to build in my students. And if I cannot build that confidence, and I am telling you, sir, I am a very bad teacher if I cannot build that confidence in you people. The role of a teacher is actually mainly to build that confidence in students and say that whatever it happens, you will do it. And I want to build that in you people.